Chapter 2, Program Structure. And my heart glows bright red under my filmy translucent skin, and they have to administer 10 cc of JavaScript to get me to come back. I respond well to toxins in the blood. Man, that stuff will kick the peaches right out of your gills. Why, poignant guide to Ruby. In this chapter, we will start to do things that can actually be called programming. We will expand our command of the JavaScript language beyond the nouns and sentence fragments we've seen so far to the point where we can express meaningful prose. Expressions and statements. In Chapter 1, we made values and applied operators to them to get new values. Creating values like this is the main substance of any JavaScript program. But that substance has to be framed in a larger structure to be useful. That's what we'll cover in this chapter. A fragment of code that produces a value is called an expression. Every value that is written literally, such as 22 or psychoanalysis, is an expression. An expression between parentheses is also an expression, as is a binary operator applied to two expressions or a unary operator applied to one. This shows part of the beauty of a language-based interface. Expressions can contain other expressions in a way similar to how subsentences in human language are nested. A subsentence can contain its own subsentences and so on. This allows us to build expressions that describe arbitrarily complex computations. If an expression corresponds to a sentence fragment, a JavaScript statement corresponds to a full sentence. A program is a list of statements. The simplest kind of statement is an expression with a semicolon after it. This is a program. It is a useless program, though. An expression can be content just to produce a value, which can then be used by the enclosed code. However, a statement stands on its own. So if it doesn't affect the world, it's useless. It may display something on the screen, as with console.log, or change the state of the machine in a way that will affect the statements that come after it. These changes are called side effects. The statement in the previous example just produces the values 1 and true and then immediately throws them away. This leaves no impression on the world at all. When you run this program, nothing observable happens. In some cases, JavaScript allows you to omit the semicolon at the end of a statement. In other cases, it has to be there, or the next line will be treated as part of the same statement. The rules for when it can be safely omitted are somewhat complex and error-prone. So in this book, every statement that needs a semicolon will always get one. I recommend you do the same, at least until you've learned more about the subtleties of missing semicolons. Bindings. How does a program keep an eternal state? How does it remember things? We have seen how to produce new values from old values, but this does not change the old values, and the new values must be used immediately or will dissipate again. To catch and hold values, JavaScript provides a thing called a binding or variable. That gives us a second kind of statement. The special word, keyword, let, indicates that this sentence is going to define a binding. It is followed by the name of the binding, and if we want to immediately give it a value, by an equals operator or an expression. The example creates a binding called caught and uses it to grab hold of the number that is produced by multiplying 5 by 5. After a binding has been defined, its name can be used as an expression. The value of such an expression is the value of the binding currently holds. Here's an example. When a binding points at a value, that does not mean it's tied to that value forever. The equals operator can be used at any time on existing bindings to disconnect them from their current value and have them point to a new one. You should imagine bindings as tentacles rather than boxes. They do not contain values, they grasp them. Two bindings can refer to the same value. A program can access only the values to which it still has a reference. When you need to remember something, you either grow a tentacle to hold on to it, or reattach one of your existing tentacles to it. Let's look at another example. To remember the number of dollars that Luigi still owes you, you create a binding. When he pays back $35, you give this binding a new value. When you define a binding without giving it a value, the tentacle has nothing to grasp, so it ends in thin air. If you ask for the value of an empty binding, you'll get the value undefined. A single let statement may define multiple bindings. The definitions must be separated by commas. The words var and const can also be used to create bindings in a similar fashion to let. The first of these, var, short for variable, is the way bindings were declared in pre-2015 JavaScript, when let didn't exist yet. I'll get back to the precise way it differs from let in the next chapter. For now, remember that it mostly does the same thing, but we will rarely use it in this book because it behaves oddly in some situations. The word const stands for constant. it defines a constant binding, which points to the same value for as long as it lives. This is useful for bindings that just give a name to a value so that you can easily refer to it later. Binding names. Binding names can be any sequence of one or more letters. Digits can be part of binding names. Catch-22 is a valid name, for example, but the name must not start with a digit. A binding name may include $signs or underscores, but no other punctuation or special characters. Words with special meaning, such as let, are keywords and may not be used as binding names. There are also a number of words that are reserved for use in future versions of JavaScript, which also can't be used as binding names. The full list of keywords and reserved words is rather long. Break, case, catch, class, const, continue, debugger, default, delete, do, else, enum, export, extends, false, finally, for, function, if, implements, import, interface, in, an instance of, let, new, package, private, protected, public, return, static, super, switch, this, throw, true, try, type of, var, void, while, with, yield. Don't worry about memorizing this list. When creating a binding produces an unexpected syntax error, check whether you're trying to define a reserved word. The environment. The collection of bindings and their values that exist at a given time is called the environment. When a program starts up, this environment is not empty. It also contains bindings that are part of the language standard, and most of the time, it also has bindings that provide ways to interact with the surrounding system. For example, in a browser, there are functions to interact with the currently loaded website and to read mouse and keyboard input. Functions. A lot of the values provided in the default environment have the type function. A function is a piece of a program wrapped in a value. Such values can be applied in order to run the wrapped program. For example, in a browser environment, the binding prompt holds a function that shows a little dialog asking for user input. It is used like this: executing a function called invoking, calling, or applying it. You can call a function by putting parentheses after an expression that produces a function value. Usually, you'll directly use the name of the binding that holds the function. The values between the parentheses are given to the program inside the function. In the example, the prompt function uses a string that we give it as text to show in the dialog box. Values given to functions are called arguments. Different functions might need a different number or different type of arguments. The prompt function isn't used much in modern web programming, mostly because you have no control over the way the resulting dialog looks, but it can be helpful in toy programs and experiments. The console.log function. In the examples, I use console.log to output values. Most JavaScript systems, including all modern web browsers and Node.js, provide a console.log function that writes its output to some text output device. In browsers, the output lands in the JavaScript console. This part of the browser interface is hidden by default, but most browsers open it when you press F12 or, on a Mac, Command Option I. If that does not work, searching through the menus for an item named Developer Tools or similar. When running the examples on your own code on the pages of this book, console.log output will be shown after the example instead of in the browser's JavaScript console. Though binding names cannot contain period characters, console.log does have one. This is because console.log isn't a simple binding, but an expression that retrieves the log property from the value held by the console binding. We'll find out exactly what this means in Chapter 4. Return values. Showing a dialog box or writing text to the screen is a side effect. Many functions are useful because of the side effects they produce. Functions may also produce values, in which case they don't need to have a side effect to be useful. For example, the function math.max takes any amount of number arguments and gives back the greatest. When a function produces a value, it's said to return that value. Anything that produces a value is the expression in JavaScript, which means that function calls can be used with larger expressions. In the following code, a call to mathmin, which is the opposite of mathmax, is used as part of a plus expression. Chapter 3 will explain how to write your own functions. Control flow. When your program contains more than one statement, the statements are executed as though they were a story, from top to bottom. For example, the following program has two statements. The first asks the user for a number, and the second, which is executed after the first, shows the square of that number. The function number converts a value to a number. We need that conversion because the result of prompt is a string value and we want a number. There are similar functions called string and boolean that convert values to those types. Here is the rather trivial schematic representation of a straight line control flow. Conditional execution. Not all programs are straight roads. We may, for example, want to create a branching road where the program takes the proper branch based on the situation at hand. This is called conditional execution. Conditional execution is created with the if keyword in JavaScript. In the simple case, we want some code to be executed if and only if a certain condition holds. We might, for example, want to show the square of the input only if the input is actually a number. With this modification, if you enter parrot, no output is shown. The if keyword executes or skips a statement dependent on the value of a Boolean expression. The deciding expression is written after the keyword, between parentheses, followed by the statement to execute. The number is nan function is a standard JavaScript function that returns true only if the argument it is given is nan. The number function happens to return nan when you give it a string that doesn't represent a valid number. Thus, the condition translates to unless the number is not defined, do this. The statement after the if is wrapped in braces in this example. The braces can be used to group any number of statements into a single statement called a block. You could also have omitted them in this case, since they hold only a single statement. But to avoid having to think about whether they are needed, most JavaScript programmers use them in every wrapped statement like this. We'll mostly follow that convention in this book except for the occasional one-liner. You often won't just have code that executes when a condition holds true, but also code that handles the other case. This alternate path is represented by the second arrow in the diagram. You can use the else keyword together with if to create two separate alternative execution paths. If you have more than two paths to choose from, you can chain multiple if-else pairs together. Here's an example. The program will first check whether num is less than 10. If it is, it chooses that branch, shows small, and is done. If it isn't, it takes the else branch, which contains a second if. If the second condition less than 100 holds, that means the number is at least 10 but below 100 and medium is shown. If it doesn't, the second and last else branch is chosen. The schema for this program looks something like this. While and do loops. Consider a program that outputs all even numbers from 0 to 12. One way to write this is as follows. That works, but the idea of writing a program is to make something less work, not more. If we needed all even numbers less than 1,000, this approach would be unworkable. What we needed to do is run a piece of code multiple times. This form of control flow is called a loop. Loop and control flow allows us to go back to some point in the program where we were before and repeat it with our current program state. If we combine this with a binding that counts, we can do something like this. A statement starting with the keyword while creates a loop. The word while is followed by an expression in parentheses and then a statement, much like if. The loop keeps entering that statement as long as the expression produces a value that gives true when converted to Boolean. The number binding demonstrates the way a binding can track the progress of a program. Every time the loop repeats, number gets a value that is 2 more than its previous value. At the beginning of every repetition, it is compared with the number 12 to decide whether the program work is finished. As an example that actually does something useful, we can now write a program that calculates and shows a value of 2 to the 10th power. We use 2 bindings, one to keep track of the result and one to count how often we have multiplied this result by 2. The loop tests whether the second binding has reached 10 yet, and if not, updates both bindings. The counter could also have started at 1 and checked for less than or equal to 10, but for reasons that will become apparent in Chapter 4, it is a good idea to get used to counting from 0. Note that JavaScript also has an operator for exponentiation to **10, which you would use to compute this in real code, but that would have ruined the example. A do loop is a control structure similar to a while loop. It differs only on one point. A do loop always executes its body at least once, and it starts testing whether it should stop only after that first execution. To reflect this, the test appears after the body of the loop. This program will force you to enter your name. It will ask again and again until it gets something that is not an empty string. Applying the !not operator will convert a value to a Boolean type before negating it, and all strings except an empty string convert to true. This means the loop continues going round until you provide a non-empty name. Indenting code. In the examples, I've been adding spaces in front of the statements that are part of some larger statement. These spaces are not required. The computer will accept the program just fine without them. In fact, even the line breaks in programs are optional. You could write a program as a single long line if you felt like it. The role of this indentation inside blocks is to make the structure of the code stand out to human readers. In code where new blocks are opened inside other blocks, it can become hard to see where one block ends and another begins. With proper indentation, the visual shape of a program corresponds to the shape of the blocks inside it. I like to use 2 spaces for every open block, but tastes differ. Some people use 4 spaces and some people use tab characters. The important thing is that each new block has the same amount of space. Most code editor programs, including the one in this book, will help by automatically indenting new lines the proper amount. For loops. Many loops follow the pattern shown in the while examples. First, a counter binding is created to track the progress of the loop. Then comes a while loop, usually with a test expression that checks whether the counter has reached its end value. At the end of the loop body, the counter is updated to track progress. Because this pattern is so common, JavaScript and similar languages provide a slightly shorter and more comprehensive form, the for loop. This program is exactly equivalent to the earlier even number printing example. The only change is that all the statements that are related to the state of the loop are grouped together after the for. The parentheses after a for keyword must contain 2 semicolons. The part before the first semicolon initializes a loop, usually by defining a binding. The second part is the expression that checks whether the loop must continue. The final part updates the state of the loop after every iteration. In most cases, this is shorter and clearer than a while construct. This is the code that computes 2 to the 10 using for instead of while. Breaking out of a loop. Having the looping condition produce false is not the only way a loop can finish. The break statement has the effect of immediately jumping out of the enclosing loop. Its use is demonstrated in the following program, which finds the first number that is both greater than or equal to 20 and divisible by 7. Using the remainder modulo operator is an easy way to test whether a number is divisible by another number. If it is, the remainder of the division is 0. The for construct in the example does not have a part that checks for an end of the loop. This means the loop will never stop unless the break statement is executed. If you were to remove that break statement, or you accidentally write an end condition that produces always true, your program will get stuck in an infinite loop. A program stuck in an infinite loop will never finish running, which is usually a bad thing. If you create an infinite loop, in one of the examples in these pages, you'll usually be asked whether you want to stop the script after a few seconds. If that fails, you'll have to close the tab you're working in to recover. The continue keyword is similar to break in that it influences the progress of a loop. When continue is encountered in a loop body, control jumps out of the body and continues with the loop's next iteration. Updating bindings succinctly. Especially when looping, a program often needs to update a binding to hold a value based on that binding's previous value. JavaScript provides a shortcut for this. Similar shortcuts work for many other operators, such as result times equals 2 to double result or counter minus equals 1 to count downwards. This allows us to further shorten our counting example. For counter plus equals 1 and counter minus equals 1, there's even shorter equivalents, counter plus plus and counter minus minus. Dispatching on a value with switch. It is not uncommon for code to look like this. There is a construct called switch that is intended to express such a dispatch in a more direct way. Unfortunately, the syntax JavaScript uses for this, which is inherited from the C Java line of programming languages, is somewhat awkward. A chain of if statements may look better. Here's an example. You may put any number of case labels inside the block opened by switch. The program will start executing on the label that corresponds to the switch that switch was given or to default if no matching value is found. It will continue executing even across other labels until it reaches a break statement. In some cases, such as the sunny case in the example, this can be used to share some code between cases. It recommends going outside for both sunny and cloudy weather. Be careful though, it's easy to forget such a break, which will cause the program to execute code you do not want executed. Capitalization. Binding names may not contain spaces, yet it is often helpful to use multiple words to clearly describe what the binding represents. These are pretty much your choices for writing a binding name with several words in it. The first style can be hard to read. I rather like the look of the underscores, though that style is a little painful to type. The standard JavaScript functions in most JavaScript programmers follow the final style. They capitalize every word except the first. It's not hard to get used to little things like that, and code with mixed naming styles can be jarring to read, so we follow this convention. In a few cases, such as a number function, the first letter of a binding is also capitalized. This was done to mark the function as a constructor. It will become clear what a constructor is in Chapter 6. For now, the important thing is not to be bothered by this apparent lack of consistency. Comments. Often raw code does not convey all the information you want a program to convey to human readers, or it conveys it in such a cryptic way that people might not understand it. At other times, you might just want to include some related thoughts as part of your program. This is what comments are for. A comment is a piece of text that is part of a program but is completely ignored by the computer. JavaScript has two ways of writing comments. To write a single line comment, you can use 2/ characters and then the comment text after it. A 2/ characters comment goes only to the end of the line. A section of line between / and / and */ will be ignored in its entirety regardless of whether it contains line breaks. This is useful for adding blocks of information about a file or a chunk of a program. Summary. You now know that a program is built out of statements, which themselves sometimes contain more statements. Statements tend to contain expressions, which themselves can be built out of smaller expressions. Putting statements after one another gives you a program that is executed from top to bottom. You can introduce disturbances into the flow of control by using conditional if, else, and switch, and looping, while, do, and for statements. Bindings can be used to file pieces of data under a name, and they are useful for tracking the state of your program. The environment is the set of bindings that are defined. JavaScript systems always put a number of useful standard bindings into your environment. Functions are special values that encapsulate a piece of a program. You can invoke them by writing function name, argument 1, argument 2. Such a function call is an expression and may produce a value. Exercises. If you are unsure how to test your solutions to the exercises, refer to the introduction. Each exercise starts with a problem description. Read the description and try to solve the exercise. If you run into problems, consider reading the hints after the exercise. You can find full solutions to the exercises online at eloquentjavascript.net/code. If you want to learn something from the exercises, I recommend looking at the solutions only after you've solved the exercise, or at least after you've attacked it long and hard enough to have a slight headache. Looping a triangle. Write a loop that makes 7 calls to console.log to produce the following triangle. It may be useful to know that you can find the length of a string by writing .length after it. Most exercises contain a piece of code that you can modify to solve the exercise. Remember that you can click code blocks to edit them. FizzBuzz. Write a program that uses console.log to print all the numbers from 1 to 100 with 2 exceptions. For numbers divisible by 3, print fizz instead of the number, and for numbers divisible by 5 and not 3, print buzz instead. When you have that working, modify your program to print FizzBuzz for numbers that are divisible by both 5 and 3, and print fizz or buzz for numbers divisible by only one of those. This is actually an interview question that has been claimed to weed out a significant percentage of programmer candidates, so if you solved it, your labor market value just went up. Chessboard. Write a program that creates a string that represents an 8x8 grid using newline characters to separate lines. At each position in the grid, there's either a space or a hash character. The characters should form a chessboard. Passing the string console.log should show something like this. When you have a program that generates this pattern, define a binding size equals 8 and change the program so that it works for any size, outputting the grid of a given width and height.